Hi, I'm Jessi Stark, a student at the University of Calgary. I'm presenting on behalf of my research team, which includes myself, Fraser Anderson and George Fitzmaurice at Autodesk Research, and Somanath at the University of Victoria. Today I'll be presenting our project MakeAware, designing to support situation awareness in makerspaces. Our work aims to support novices in makerspaces, inspired by the knowledge that making activities have become increasingly popular in both the research community and public practice, and that individuals with a variety of skill levels are undertaking making activities using a variety of tools, materials, and techniques. We use evidence presented in related work, as well as interviews we did with expert makers about their workflows, to define some common problems faced by novices that are not common to experts. In Build in Progress, Tiffany Sang discusses the fact that instructions are most often provided in a linear format, but making rarely happens that way. Nathaniel Hudson writes about how novices in 3D printing often do not attempt a second 3D printing project because the process is difficult and confusing for them. The interviews we conducted with experts validated these points and also brought out another key flaw in the workflows of novices. Sometimes, rather than getting overwhelmed by the scope of what they have to do, as Hudson discussed, they will get too caught up in small tasks and lose sight of their overall goal. From related work and our interviews, we summarize the workflows of experts and novices for comparison. Expert makers put a lot of emphasis on planning at the start of a project, whereas novices are more likely to dive in with only a general idea of what they want to accomplish. Experts have the background knowledge and skills to choose a tool suitable for the current task, but novices lack this knowledge and will tend toward using a familiar tool, whether or not it's the correct tool for the job. Experts are able to easily break down large projects into smaller steps while understanding how everything will come together in the end. Novices, on the other hand, will feel overwhelmed by large projects or get too caught up in small details and forget why they're doing it. If things don't work out as planned, experts are more likely to revise their plans or try a different approach. Novices are more likely to give up or not to attempt another project in the future. To support novices in following a workflow more similar to experts, we had to think about why these workflows are so different. So we thought maybe it's because novices are simply unaware of so many things that experts are aware of. They don't know where to find the tools or which tools are best for their project. They often aren't aware of how to use the tools or materials, or even what results they should expect from using them. This led us to Ensley's situation awareness framework. The basic premise is that having complete situation awareness will allow a person to make a correct decision or to make fewer mistakes. The person's background knowledge is the foundation for their awareness level. Perception builds on this, followed by comprehension, and finally projection. These three levels constitute a person's situation awareness. Ideally, a person could become completely aware of their situation and as a result will be able to take the correct action based on the current situation. Now I'll talk briefly about each of these levels. Perception is essentially the ability to notice cues in the environment. This level is made of two factors. The first is categorization of information, which is largely affected by the extent of a person's background knowledge. With more knowledge, more refined categories of information can be defined in their mind. Then when they notice something, they are able to fit that information into a more specific category of knowledge. The second factor is data-driven processing, which leads the person directly into level 2 of situation awareness, which is comprehension. The main factor at this level is the goal-driven processing that takes place. There's a constant ongoing trade-off between goal-driven processing at this level and data-driven processing at the level below. This is constantly happening in a person's mind, where the goal defines what data we look for in the environment, and in turn, the data in the environment refines our goals. The top level of situation awareness is projection. This includes factors like forming correct expectations, dynamic goal selection according to the current situation, and automatic action selection, which is the second nature type of action we all do when we're really familiar with something. If a person has complete awareness at this level, they should be able to perform the correct action for the situation. So let's look at a quick example of how this might look. When a novice sees this, they might think this is a power tool. If an expert sees it, they would probably think this is a router. Because of their background knowledge, they are able to process this data and place the information in a more specific category of knowledge. Next, the novice might be wondering what they can do with this tool. They might wonder, can I use this to engrave metal? The expert would be more likely to think something along the lines of, I can use this to cut shapes out of wood. They've noticed the tool because their goal is to cut shapes in wood. They have more advanced goal-driven processing. The novice, whose goal is to engrave metal, has processed incorrectly. Then they both attempt the task. The result is that the novice has broken the bits on the router and doesn't understand how this happened, while the expert has succeeded in completing their task. In other words, they selected the correct action. This leads to our main research questions. Is situation awareness a suitable framework to support novice makers? Based on examples like I just discussed, we think it will be. We also want to know, how can we design a tool that supports situation awareness in a makerspace? To answer our questions, we designed MakeAware, a situation awareness support system for novice makers. We started by designing for each level of situation awareness. We asked, what do makers need to perceive in a makerspace? Some ideas we had were the location and availability of tools, and the presence and work areas of other makers in the space. We supported perception using environmental cues spread throughout the space. We implemented task beacons that show users where their currently required tools are located. Next, tools are located at stations with green lights. This shows all their possible options. When they selected a task to complete, the light turns blue, and they know this is where they need to be now. The lights also convey tool availability information, show their default task-related colors, the green and the blue, while the tools are present. The light will turn as a warning to the maker that they may not be able to this station. Tools are tracked using proximity sensors embedded in the shelves. To support level 2, we had to think about what makers will need to comprehend while making. Some ideas we came up with were the purpose and correct use of tools, which tools are required based on the current goal, and the reason they're doing what they're doing. The blue lights also provide they show the location tools based on the current goal, thereby supporting goal-driven processing. The project map supports the user in their comprehension of why it portrays how each task fits into the project using branches. It also supports their comprehension of how to do it and what. For the full task instructions, they are able to further comprehend, building background knowledge on tool use through the videos and seeing a list of everything they need. Finally, we thought about what information makers need to be able to project into the future. This includes things like the end goal, the order in which they should do the tasks, and how the result of the current goal will future states. We supplied a product at the start to give makers a good sense of where they should end up and the types of tools or materials they may decide to use along the way. The map and task instructions also have features which support projections, such as the task metadata and trajectory on the project map. We set this all up in a makerspace according to a sample project we chose, which was a set of laser-cut wooden bookends. For this project, we included 4 stations: the laser cutter, the bandsaw, the fume hood for paints, and a table for with hand tools. Each station has a light bulb that indicates the station according to tool availability and project progress. To evaluate the system, they make MakeAware to laser cut and build the wooden bookends. Finished, they filled out a post-study questionnaire to help us evaluate how well the system supported their situation awareness and their ability to make sense during the project. We found that the hue supported comprehension well, especially when they act as task beacons. We also found that participants' main focus was on the tablet interface, so did the information conveyed, they failed to notice them while choosing a task. The project map was very successful at supporting both comprehension and projection. No participant gave a rating less than neutral at either awareness level, and over half of participants agreed or strongly agreed at both levels. Looking back at the expert workflow, the situation awareness framework helped novices to follow a similar workflow. Using MakeAware, novices placed more emphasis on planning because we asked them to document their planning stage. They were able to choose suitable tools for different tasks by watching videos to see how they should be used. They followed through the entire project step by step while still understanding how each step led to the next using the project map. If they decided to revise their plans or iterate on what they had done previously, MakeAware contains suggestions for alternate methods of completing a task. So in the end, the workflows followed by these novice makers more closely resembled the workflows of expert makers. Thank you for listening to this presentation. Check out our paper for more details about the project, or contact me at jtstark@ucalgary.ca with any questions you still have about it.